Dear students, in this session we are going to continue giving results. Result 12. Equation of ellipse. Modulus of z minus z1 plus modulus of z minus z2 equal to 2a is the equation of ellipse having foci at z1 and z2. Z1 and Z2 fixed points are called foci in ellipse. So modulus of z minus z1 plus modulus of z minus z2 equal to a represents ellipse, where 2a is greater than distance between z1 and z2, and a belongs to R plus, that is positive real numbers. Next, equation of hyperbola. Modulus of z minus z1, here minus modulus of z minus equal to a is the equation of hyperbola having the previous definition also we should have having here. I think I would have written mistakenly having. So you have to complete having foci at z1 and z2, where 2a is less than modulus of z1 minus z2 and a belongs to R plus. Some properties of triangle. If the vertices of a triangle are representing the complex numbers Z1, Z2, and Z3. Then centroid representing the complex number Z0 is given by Z0 equal to Z1 plus Z2 plus Z3 by 3. If the vertices of an equal triangle representing the complex numbers Z1, Z2 and Z3, then the circumcenter represents the complex number Z0 is given as Z1 square plus Z2 square plus Z3 squared equal to 3 Z0 squared. So vertices of equal triangle representing complex numbers Z1, Z2 and Z3. Circumcenter represents the complex number Z0 is given as Z1 square plus Z2 square plus Z3 squared equal to 3 Z0 squared. Vertices of an equilateral triangle will be represented by Z1, Z2 and Z3 when Z1 square plus Z2 square plus Z3 square equal to Z1 Z2 Z2 Z3 Z3 Z1 or 1 by Z1 minus Z2 equal to plus 1 by Z2 minus Z3 plus 1 by Z3 minus Z1 equal to 0. In the vertices of an isosceles triangle, be represented by Z1, Z2 and Z3, right angled at a point represent Z2. So it's right angled at Z2. Then Z1 square plus twice Z2 square plus Z3 squared equal to 2Z2 into Z1 plus Z3. Next result, in the vertices of isosceles triangle, represent the complex numbers Z1, Z2 and Z3. Right angled at a point represents Z3, then Z1 minus Z2 whole squared equal to twice Z1 minus Z3 into Z3 minus Z2. If 3 points represent Z1, Z2, Z3, are collinear, Z3 minus Z1 by Z2 minus Z1 equal to Z3 bar minus Z1 bar divided by Z2 bar minus Z1 bar. Standard loci in the organ plane. If a point moves under some geometric conditions, path will be traced. That is loci. Locus. Loci means plural form of locus. If Z is a variable point, Z is a variable point and Z1 and Z1 comma Z2 are two fixed points in the organ plan, then modulus of Z minus Z1 equal to modulus of Z minus Z2 implies locus of Z is the perpendicular bisector of the line segment joining Z1 and Z2. we have 2 points, z1, z2. It's a moving point, it's a variable point z. Wherever it moves, the distance between these 2 points and these 2 points are the same. Therefore, it will be a perpendicular bisector. Modulus of z minus z1 plus modulus of z minus z2 equal to constant not equal to modulus of z1 minus z2. Locus of z is an ellipse. Modulus of z minus z1 equal to plus modulus of z minus z2 equal to modulus of z1 minus z2. Locus of z is the line segment joining z1 and z2. Modulus of z minus z1 minus modulus of z minus z2 equal to modulus of z1 minus z2. Locus of z is a straight line joining z1 and z2, but z does not lie between z1 and z2. Modulus of z minus z2 minus modulus of z minus 2 equal to constant not equal to z1 minus modulus of z1 minus z2, which implies locus of z is a hyperbola. modulus of z minus whole square plus modulus of z minus z whole square equal to modulus of z1 minus z2 the whole square. Which implies locus of z is a circle with z1 and z2 as the extremities of diameter. Modulus of z minus n equal to k into modulus of z minus z2 k not equal to 1. Locus of z is a circle. Argument of z minus z1 divided by z minus z2 equal to alpha, that is fixed constant, which implies locus of z is a segment of a circle. Argument of z minus z1 divided by z minus z2 equal to plus or minus pi by 2. Locus of z is a circle with z1 and z2 as the vertices of diameter. If argument of z minus z1 by z minus z2 equal to zero or pi implies locus of z is a straight line passing through Z1 and Z2. Next, angle between two lines. That is concept of rotation. So P represents Z1, Q represents Z2, R represents Z3. So Z2 makes angle theta 1 with real axis. It makes Z theta 2 with the real axis. So angle between PR and PQ is theta. Consider 3 points: P of Z1, Q of Z2, and R of Z3. Then angle between PR and PQ or PQ and PR, that is PQ and PR. In this direction, that is counterclockwise direction. Is theta equal to theta 2 minus 1, theta 2 minus theta 1 equal to argument of PR minus argument of PQ, length PQ, or PR vector PQ vector. Argument of PR Z3 minus Z1, terminal point minus initial point. Here PQ Z2 minus Z1. Therefore, theta equal to argument of Z3 minus Z1 divided by Z2 minus Z1. If PR is perpendicular to PQ, then argument of Z3 minus Z1 divided by Z2 minus Z1 equal to plus or minus pi by 2. Which implies Z3 minus Z1 by Z2 minus Z1 is purely imaginary. That is Z3 minus Z1 divided by Z2 minus Z1 equal to Z3 bar minus Z1 bar divided by Z2 bar minus Z1 bar. Since a complex number Z is purely imaginary, if Z equal to minus Z bar. Consider argument plane. Here theta, P of Z1, Q of Z2, R of Z3, S of Z4. Consider 4 points P, Q, R and S. Representing Z1, Z2, Z3 and Z4. Respectively. The angle between SR and QP is theta equal to argument of Z3 minus Z4 divided by Z1 minus Z2. If SR and QP be perpendicular, then theta equal to pi by 2. Then Z3 minus Z4 theta equal to, we can say, plus or minus pi by 2. Then Z3 minus Z4 by Z1 minus Z2 is purely imaginary. Which implies Z3 minus Z4 divided by Z1 minus Z2 equal to Z3 bar minus Z4 bar by divided by Z1 bar minus Z2 bar. Or alternatively, here minus of Z3 bar minus Z4 bar divided by Z1 bar minus Z2 bar. The previous case also Z3 minus Z1 bar divided by Z2 minus Z2 equal to minus of Z3 bar minus Z1 bar divided by Z2 bar minus Z1 bar. Make this correction. There should be negative sign since Z equal to minus, you have to apply Z equal to minus Z bar. If I have missed minus sign there, just take that instead of minus and here. So here Z3 minus Z4 divided by Z1 minus 2 equal to minus of Z3 bar minus Z4 bar divided by Z1 bar minus Z2 bar. Or alternatively, Z3 minus Z4 divided by Z1 minus Z2 equal to I into K. For some K belongs to R minus 0. Implies Z3 minus Z4 equal to IK into Z1 minus Z2. Multiplying a complex number Z by I is equivalent to rotating the image of Z in organ plane by 90 degree about origin in anti-clockwise. As modulus Z equal to modulus Iz on argument of Iz by Z equal to argument of I equal to pi by 2. Next, multiplying complex power Z by minus I is equal to rotating the image of Z in organ plane by 90 degree about origin in clockwise direction. If you rotate the anti-clockwise direction, it is equal to multiply by I. Multiply by any number by minus I means rotating the number in the clockwise direction by 90 degree about origin. Multiplying a complex number Z by omega is equivalent to rotating the image of Z in organ plane by 120 degree or 240 degree about origin in anti-clockwise. and argument of omega z minus 0 omega z, argument of omega minus 0 omega, so z equal to argument of omega, that is equal to 120 minutes 2 pi by 3 or 240 minutes 4 pi by 3. Angles of a triangle. A of Z1, B of Z2, C of Z3. If Z1, Z2 and Z3 if A comma B comma C represents Z1, Z2 and Z3, and ABC are vertices of triangle ABC described in the counterclockwise sense. That is ABC, that is clockwise, counterclockwise or anti-clockwise. Then Z3 minus Z1 divided by Z2 minus Z1, that is CA by BA into cos A plus I sin A. Or Z3 minus Z1 divided by Z2 minus is equal to CA by BA e power IA. Similarly, we can say, we can find the other relations related to remaining angles. Here related to angle A, like that we can say related angle B, related angle C we can find. If we take angle A, Z3 minus by Z2 minus is equal to CA by BA cos A plus sin A. Then we take the anti-clockwise direction. like that. BA Z2 minus Z1, Z1 minus Z2, Z3 minus Z2, that is BA by BC into cos B plus I sin B, we can write. Z2 minus Z3 divided by Z1 minus Z3 equal to or Z1 minus Z3 minus by Z2 minus Z3 equal to CA by CB into cos C plus I sin C. So anti-clockwise direction means here the points are taken in the anti-clockwise direction. Here Z3, Z1, Z2 minus Z1 equal to CA by AB, BA by cos A plus I sin A. These rotation properties are very, very important. Triangle ABC is equilateral. If only if 1 by Z2 minus Z3 plus 1 by Z3 minus Z1 plus 1 by Z1 minus Z2 equal to 0. If only if Z1 square plus Z2 square plus Z3 squared equal to Z2 Z3 plus Z3 Z1 plus Z1 Z2. One Z2 Z3, 1 Z3 Z1, 1 Z1 Z2 equal to 0. So you have to remember all the results. Based on this organ diagram and geometrical properties, we will discuss more sums in the next class. So we have completed all concepts. Next we are going to solve problems relating to these concepts. Thank you.